Let's take a look at another example that features composition of functions. So we are given the functions p of x equal 1 over the square root of x and m of x equal x squared minus 4. We're going to be asked to find p of m of x. Now, just a reminder to you that this composition of functions, there's two ways you can notate it. You can notate it like this with the parentheses, or another way you may see this is with the little circle. So you may see p of m of x. And both of these notations mean the same thing. Basically what we're doing, just to remind you what a composition of function does, is that it takes the output value of the innermost function in the parentheses, so the m. So we take the output value of m, and that becomes the input value to p. So the output value of function m is going to become the input value of function p. We're going to take a look at function m, and that's this function right here. It's the quadratic equation, and m of x equals x squared minus 4. So that means that, again, reminding you that this notation, function notation, m of x is taking the place of y, or the output value. So the output value of function m is x squared minus 4. So we're going to take that x squared minus 4 and we're going to substitute it in for x for the input in function p. So we're going to take p of x squared minus 4. So again, that's the output value of m, and now it's going to replace x in function p because it replaces the input in function p. So that means that we're evaluating 1 over square root of x squared minus 4. Ignore the 16, it's a page number. So p of m of x then is given by the equation 1 over square root of x squared minus 4. Now, this next problem, notice how we have the functions listed in a different order, and that's going to make a lot of difference. Again, you'll either see m of p of x in this notation, or you see it with the circles m of p of x, like this, with a little open circle there, okay? Another reminder that this does not mean multiplication, as you know. This time around, we're going to take the output value from p, from function p, of function p, and it's going to become the input value of function m. Okay, so we're going to look at p of x first, and I just want to remind you that p of x is this function 1 over square root of x. So the output value of p of x is 1 over square root of x, because again, this p of x notation represents y, all right? So we're going to substitute that output value, that 1 over square root of x, into the input, or the x, of function m, okay? So we're going to go m of 1 over the square root of x. So in function m, that was our quadratic equation. Let me remind you. We are going to take the input value, the x, and that gets squared, and then you subtract a 4. Just like that, okay? Now we can do a little bit of simplifying here, because we can square this fraction, and 1 squared is 1, and square root of x squared is x, as you know, and then subtract 4. So here's what we got. That m of p of x is given by the equation 1 over x minus 4. Okay, if you followed this far, those two sections of our problem, those two parts, B and C, had to do with composition of function. And just a little review back here with part A, this is function arithmetic, so now we're dividing functions. So that is literally what you think it is. It's take your function p of x and divide it by m of x, the output value. So p of x is 1 over the square root of x, and we're going to divide that by the x squared minus 4. Now this function, this new function that you've created here by doing this division, this is not in simplified form. So we do want to simplify. This is called a complex function. Excuse me, a complex fraction. Notice how we have a fraction within a fraction? So how we get rid of that is we actually will replace this division bar, this fraction by a division. So we're going to write 1 over square root of x divided by x squared minus 4. This is a division over 1. And you remember that fractions, when you divide them, you use the reciprocal, right? You multiply by the reciprocal. So I'm just going to write 1 over square root of x times 1 over x squared minus 4. So I'm using the reciprocal here and then changing this to a multiplication just like we do with any division of fractions, right? And so our new function created by dividing the old functions p and m are, and I'm going to multiply this straight across, given by this equation, 1 over square root of x times x squared minus 4. And again, this was just like a little review of our function arithmetic, whereas the previous two problems had us give examples about composition of functions.